A man has fallen into the river in Lego City.
Build a high-speed police boat. Put it in the water.
We began the design process by researching and understanding the problem we were assigned to solve. This was to achieve the maximum displacement possible of a Lego minifigure without simply throwing it. This led to ideas of transport devices such as a car, plane, or a boat.
After having bid on boxes of building materials we thought would be the most useful and diverse, we collected our initial concept designs and discussed relevant aspects of each. After consideration of both what was available to us from the boxes and the pros and cons of each type of transport system, we decided to go forward with the idea of a boat to transport Cyborg.
The concept of a sailing boat using solely wind power was analysed. However, the success of this design would rely heavily on external factors such as weather and wind direction. We then analysed the concept of a propeller-powered multi-hull boat, which would use more materials. However, as these were readily available to us, a compromise between maximising stability and weight reduction led to the implementation of the multi-hull boat.
Our initial design consisted of two gears working together to power the propeller, which could be submerged into the water to provide the boat with greater thrust. However, as we built the boat, we faced major challenges with the gears which didn't spin together. We believe this was because the motor was rotating the driving gear too quickly for it to catch onto the gear, which would rotate the propeller with it. So we decided to have a direct connection between the motor and the propeller.
The stability of the boat is ensured by the multi-hull design as previously mentioned. The triangular hulls were made from hollow lengths of wood with a low density wood placed on top of these to improve overall structural rigidity. The plastic was then used to create a light, stiff connection between the holes upon which we could place the casing which housed the minifigure as well as our motorised propeller system.
The boat is powered using a propeller mounted to the back of the 3D printed casing, which pushes air instead of a conventional water propeller. We decided to use this method as the propeller needed to be directly driven by the motor, which cannot be submerged into water. However, this design came at a cost due to the intake aperture of the propeller being partially blocked by the casing, a problem we acknowledged by minimizing the size of the casing.
An issue we encountered during the first test run was that the boat would stay off to the right due to a weight imbalance. We rectified this by adding weight to the left side of the boat in order to increase stability, hence increase displacement. Our second and third runs show a vast improvement on the initial displacement achieved by the factor of more than 3.5, highlighting the balance issue had somewhat been solved.
In our third and final test run, our boat was able to achieve a displacement of 7.4 meters. In hindsight, we could have improved on this by ensuring a solid connection between the wires connecting the motor to the battery to ensure maximum power delivery to the propeller. Despite this, our boat was a success, as it achieved the goal we set out to achieve.
Can he drive?
Can he drive? You know what DK stands for?
Donkey Kong?
Drift King.
Drift? What do you mean, drift?